Hey, I'm Pat, and in this video I will be explaining metatables in Roblox. I won't be going over like an example at the end of the video because this video might run a little long, so I'm not going to bother. I have kind of a lot to go over. So, metatables are basically a way of creating much more powerful tables. It's a very powerful resource for Roblox, for Lua at least, to make Lua a lot more versatile in what you can do with it. It's very unique as well. So pretty much what a metatable does is it allows you to have events on a table, if you want to think of it that way. They're not technically events, but you can call them events. So I'm gonna make a script and we're gonna start off here. So the way a metatable works is it has things called metamethods, and hopefully my editor will put like some metamethods on the screen, like a screenshot or whatever. But the first one I'm going to go over is index, which is really like the most important one. So all metamethods are going to start with like a double underscore. So what we're going to need first is our table. So we're just going to call this a meta table equals, and then it's just gonna be a normal empty table. And now what we can do with our table is we can add metamethods to it. So we can do table dot underscore underscore, and then we can do index equals function blah blah blah, right? So this is a meta method called index, and we index it just like on any table. So we can index any table with a meta method like this, and then we can set it to have a callback. And this can actually be other things than a function. This could also be, say, a value like 3, and this could also be another table instead, like just an empty table or a table with values in it. And what index does is it will fire every time the table that it's attached to is indexed with a nil index. So obviously metatable does not have any indexes right now, but if we were to say try and index it with something that doesn't exist, like let's say hello, let's try this. Let's try print hello metatable, and then we're going to try and print the value of the index hello, right? So it's going to search this table, and we're going to look for the key hello, and we're going to try and find that value, and it's going to notice that there isn't a value. So what it's going to end up doing is it's going to go to index, the meta method here, and it's going to call this function, or it's going to use the value that it's given here. So what we can do here is we can print world. We can give it assign index to our value world, and if I go ahead and show you, test run, that's because I actually did this wrong. I knew that was going to happen. So the last thing we have to do is actually make a table, or an actual proper table. We have to use this set meta table. So what you do normally is you have a table with all your meta methods and anything else you might need in it, and you attach that meta table to another table, pretty much using set meta table. So the first argument would be your table, and then a second one would be your meta. So that pretty much attaches all the meta methods from this table to the table that we have here, which is just going to be an empty table, but we can have a table that we already defined and later on attach the table to our meta table if we wanted to. So we go ahead and run it now, and it still says nil. What? Wait. Oh, that's because we're still indexing metatable. We have to index our new table. Try it now. Bro, what? What is hold on. This doesn't make any sense to me. I think this actually needs to be a table. Alright, so what we're going to do instead is we're going to make a separate table with an index hello, and we're going to give it the value world. Let's see if this works now. That should work. That should work. Alright, so you can see there it says world. So we can't actually return just a value. So it's either a table or a function. I got that confused. Alright, I'm probably gonna, yeah, I don't know. But, so that works, right? So the way this works is it will search, it will Alright, hold on. So it tries to index table, realizes that there's no index called hello. So then it looks at the meta table that it has and sees that it has a meta method for the index. So it knows that we just tried to index a nil index inside of our table, right? Since table is actually technically empty, it's just this empty table. So it doesn't have anything inside of it. So what we do is we check its index meta method instead, and we see that it has a separate table, and inside this table it has a key called hello, and its value is world. So what it does is it ends up indexing it, since it has the same key here. So indexes it with the same key and gets the value. Now what we can also do is do a function. I swear I know what I'm doing, guys. I swear. Alright, you gotta trust me. You gotta trust me here. Although I don't have metatables memorized too well because I don't use them that often. Well, I do, but like it's kind of hard to explain. But I actually forgot the arguments for index. I think it's table, which is the table that was indexed, and then this would be the next would be the index. So I think there's actually a third argument, if I'm not wrong. There might not be. I don't think there is. But so I believe there's two indexes. The first one being the table that was indexed, which would be the table that we set the meta table to, which would be this empty table, or our table value variable here. And then the second one would be the index that we tried to index with, so it would be hello. So if we go ahead and just print index, it should print hello. Hello, nil. Okay, see, it works. So now what we can do here is we can actually return a different values. To say we want to return world, just kind of like how we did before. What it will do is it'll call that function, and it'll take the return value and it'll use that instead. So see, it said world. So we could do pretty much whatever we wanted inside this function and use it as a custom way of doing something. Another way to look at this is, say this is a very common example, is pretty much like a monster system where you have like different kinds of monsters, and each monster has like different stats inside their table. So say like we have monsters equals table, and then what we can have is alien equals blah blah blah, and then we can give it like health equals 50, damage equals 5, something like that, right? But say we want to create a base monster, like a monster that just kind of like a base reference monster that we could use. What we could do is instead we could have a meta table which stores kind of like our base monsters. So like if we don't want to create a bunch of different monsters, or say we want to prevent there from being an error per se, we could return a separate table which has pretty much the same keys as the alien table, but instead what it will have is you know, like English. Instead it will have like some base stats that we could use. So we could give it maybe less health and less damage, but say we have like dinosaur. I don't fucking know, man. So we have alien and dinosaur. Dinosaur, they're gonna be a little bit more tanky, maybe do a bit more damage as well, since they're dinosaurs, you know. And what we can do now is we can attach our monsters table to our meta table, doing this, and then we can get its return value, which would be table. But we could also do this, just like set monsters equals set meta table, like that. Now what we can do is index monsters with alien. We'll get our alien stats, and then we'll also get another monster called I'm running out of monster names, guys. Werewolf. Oh yeah, this is a good monster name. Alright, so we'll go ahead and run it, and you'll see the first one is 5 and 50, and second one's nil. The reason for that is because yeah. How do I do this? I forget how they do this. We could do a function instead. And inside this function we can just return our base stats. kind of like that. So now if we do it, you'll see we get our alien, which is 50 health, 5 damage, and then we get our base stats for the werewolf, which is 5 and 10. And then we could even like expand on those base stats if you wanted to, or something like that. But there's a lot to do with index. There's also Rawset and Rawget. Or I don't think that actually applies for index. I believe that's for no, I think that is for new index. Rawget is for index though. So I'll go over Rawset, Rawget. Well, I should go over new index first maybe. So new index, what new index does is it's kind of similar to index, and it's kind of self-explanatory. Is it'll fire every time a new index is created inside our table, or yeah, our table. So what we can do is print new index or something like this, or we could do, I believe it also has the table and index in the parameters as well. So we could print the new index every time that a new index is created. And then the first thing we'll do is we'll go ahead and create a new index or table called hello and set it to world. Like that. Go ahead and run it. And you'll see it prints hello. So what it does is it sees that a new index was created in our attached table, and it takes the index that it takes the new index and it'll print it out. This could be useful in other cases, right? I don't have like many use cases off the top of my head, since metatables are like one of those things that I kind of had a hard time finding a use case until I started doing some really crazy wonky things. But you know, it makes sense. So say we want to create a new index inside of our table without invoking the new index meta method, which could be pretty useful in some cases. Don't ask for any cases because I don't know them off the top of my head, but Rawset and Rawget. So Rawset will pretty much set a value inside of a table, or set a key inside of a table to a value without invoking its new indexed meta method. So now what we can do is we can give it our table. So that's going to be the table that we want to add the index to, and then we'll give it the index that we want to add, which is hello, and then we'll give it the value we want to add, which is world, and then we'll print table just to show you that it was actually added to the table. Go ahead and run it. You'll see it prints hello world, but it doesn't actually print hello because it doesn't invoke the meta method. And then there's also one called index, or Rawget, which will not invoke index if it's nil. So what we can do is do Rawget, which is actually pretty useful, because say if you want to check a table to see if a value is inside the table, you might want to do that. But if you have an attached index method, it will always return true because there's not going to be a nil. It's not going to be returning nil. But if you use Rawget, you can check it without having to worry about it not returning nil. Hopefully that makes some kind of sense. But the way Rawget works is pretty much the same thing. Table, and then we give it the key that we want to get the index of, which would be hello. And we're gonna actually do Rawget before we do Rawset, because obviously if we do Rawget before, then you get the idea. But so in both these cases, we should not get print hello printed in the output. You can see we only get this table, and obviously we could print the result of Rawget because it's going to return the value, and we're going to get nil. See, it says nil, right? There's also raw equal, because there's also another meta method called equal, which will allow you to compare two tables which actually have the same metatable. So for instance, we had two tables like this, table 2, but you can see they both actually had the same metatable. They're both using this table. So what we can do is compare the two tables. say if we wanted to have a way of comparing the two tables, we could do that inside of our custom function, and we could return true or false based on that, right? So if table equals table 2, and what this will do is when we use the equals is it will invoke the attached meta method, the equals meta method, right? And in this case, we're just going to return true. I'm not going to try and do anything like stupid, but if it equals each other, then we'll print true or whatever, right? So go ahead and run it, and you'll see once we run it, nothing gets outputted. What did I do? Wait. Is that not the right? Oh no, there's no U. It's just EQ. So we do that, it says true, because we return true, and then the condition sees that as true. So it pretty much sees that as true now, and it prints true. We could also do things like give our tables multiplication and addition, and power and modulus and division, and we could concatenate them as well. Like, there's so much we could do with them. We could also create a meta method for when we try and call our table. So metatable dot underscore call, and then function table, and then obviously we could have our parameters passed here. So if we want to pass parameters to our table, we could pass it here. So param1. So now say if I want to call my table, because who doesn't want to call a table like it's a function? That's pretty cool, isn't it? Hello. So now we could call our table like it's a function and tell it to and pass it hello. And what we'll do is print out the parameter, and it should print out hello. See? Pretty it's not actually that complicated. Metatables are not that complicated. You might struggle initially to find a use case for them, but one of the best use cases for metatables is object-oriented programming, which is the main reason why I'm going over them in this video, because the next video I'm going to be covering that. But another use case, which I technically used object-oriented programming in, but I also used another thing. Pretty much what I did is I created a custom string library. So obviously we already have a string library where it has a bunch of functions in it, and we can also call methods on those strings. And what I did is I pretty much made my own custom string objects where I used equal, and I used concat, like metatable.concat. What is it? It's like, I think it's just conc. I don't know why they made the names like so weird. No, it is actually just concat. And pretty much use these meta methods to create a table, but even though it's a table, it can still be used as if it's a string, because we can concatenate it. We can use the equal method on it. We can give it functions inside the table that are similar to the string library, like string.lower and things like that. And it could actually be treated a lot like a normal string. In that case, we could also use toString. There's actually a meta method called toString, which will be called whenever you try and use toString on the given table, which is very useful for something like a custom string library, because whenever you use print on any object, it will actually automatically use toString on that object. So per se, if I want to return hello inside of here, every time we try and toString our table, what we can do is we can print out our table. So in this case, normally you would think it'd just print out an empty table, but since we're actually giving it a meta method for toString, what? I'm sorry guys, I thought I was being smart. I'm pretty sure that's how that works. Oh. I'm stupid. I forgot my underscores, guys. Alright. So try that again. And it prints hello, see? Like, exactly what I was saying, first try. I never fail. So, print will actually use toString on any of the values that it was given. And because we have metamethods for toString, we can kind of treat this table as if it's a string in that sense. So if you really want to challenge, I mean, I kind of went over how to do it already, but you can make a metatable that works exactly like a string, or like a table that works exactly like a string. So if you try and concatenate it, you can concatenate it. If you try and check if it's equal to something, you can do that. You can also print it out. You could also try and give it functions if you want. I went over how to add functions to tables in the last video, so that's not really an issue. So you could try and do that if you want, just something to mess around with. Metamethods, or metatables in general, are pretty fun and useful to have. They're very useful for object-oriented programming. I believe I already said that, but you get the idea. Yeah, that's pretty much it for this video. Thanks for watching. Yeah, hopefully it was helpful. See ya.